This is problem 15 from Special Relativity Dynamics. An electron is accelerated through a potential difference of 10 million volts starting from rest. Find its kinetic energy, momentum, and velocity. Compare its velocity to that predicted by classical physics. Okay, so we have an electron, and if you need to, you can look up in the back of the textbook the rest energy of the electron in electron volts, and I'm going to call that E naught for the rest energy. That is 511 kilo electron volts, or 0.511 mega electron volts. Then we have a potential difference of, I guess I'll just call it V, of 10 million volts. So that's 10 megavolts. Oh, I will call it delta V. So this would be like back in Physics 161. Your electron starts here, it ends over here, and the potential difference between the two plates is 10 million volts. It's starting from rest. It's going to accelerate towards the plate over here. By the time it reaches the plate here, it has some velocity, which if we were in Physics 261 is probably what we would be calculating. But here we are interested in finding the kinetic energy and we are going to find the velocity in this problem also, as well as the momentum. So what I need to do first to find the kinetic energy is remember from Physics 161, the kinetic energy is equal to the charge times the change in potential. We have an electron here. The charge on the electron is E. Maybe we should say the absolute value of the charge and the absolute value of the change in potential. So this would be E times 10 megavolts. But instead of actually putting in 1.602 times 10 to the negative 19th coulombs for the charge, we're just going to leave it as E, and that's going to give us 10 mega electron volts. If you put in 1.602 times 10 to the negative 19th coulombs for E, a coulomb times a volt is a joule, so that would get you units of joules instead of electron volts, but we like to work in electron volts in this class. So we already have our kinetic energy then. So that was something we were asked to find, right? Okay, so kinetic energy is equal to 10 mega electron volts. I also have to find the momentum and the velocity. And I want to find not the momentum P, but I want to find PC. So please, if you're asked to find the momentum for a homework problem, just give me PC. That is what I would like. Okay, so here, if we're going to use this equation to calculate the momentum, we have to know the velocity, and we have to calculate the velocity anyways. You could use the equation here to find the momentum, but you would have to find the total energy first. Well, as long as we're finding the total energy, you could use that to find the velocity. There are different ways you can find the quantities that you need in this problem, but let's just go with this. So E total is equal to gamma times mc squared. Well, this is mc squared. So that's gamma times 0.511 mega electron volts. But E total is also equal to the kinetic energy plus the rest energy. I know the kinetic energy is 10 mega electron volts, and I know the rest energy is 0.511 mega electron volts. So the total energy is 10.511 mega electron volts, but it's also equal to gamma times 0.511 mega electron volts. Therefore, gamma is equal to 10.511 0.511 mega electron volts divided by 0.511 mega electron volts. And just to be clear, this is the kinetic energy after being accelerated through the 10 million volts, and this is the total energy after being accelerated through the 10 million volts, because before the electron was at rest, so the total energy beforehand was just equal to the rest energy. Okay, so 10.511 divided by 0.511 gives us 20.55 for gamma, and gamma is equal to 1 over the square root of 1 minus v squared over c squared. Therefore, we can square both sides and take the reciprocal of both sides, and that will get us 1 over gamma squared is equal to 1 minus v squared over c squared. And then we want to solve this for v over c. So rearranging a little bit, we have v squared over c squared is equal to 1 minus 1 over gamma squared. Then take the square root of both sides, and you have v over c is equal to 1 over the square root of 1 minus 1 over gamma squared. Now, it wasn't too hard to derive that, but you might want to write this down on your equation sheet because it will just save you a few steps on other problems in the future. Okay, so it's not boxed because it's an answer. We still have to plug numbers in. It's just boxed because it's a useful equation. So this would be 1 minus 1 over 20.55 squared. And that gives us for v over c 0.9988. Therefore, the velocity is equal to 0.9988 c. Do not, under any circumstances, round a velocity like this to c. There is a big difference between something traveling at the speed of light and something traveling at 0.9988 c. So do not treat nines immediately after the decimal point as significant figures. So I would say this answer here has 2 significant figures, which is what you would get if you did c minus your velocity. Now we have to find the momentum pc. This will be very easy because pc is equal to gamma times mc squared times v over c. We know gamma is 20.55. I know mc squared is 0.511 mega electron volts, and v over c is 0.9988. Therefore, the momentum pc is equal to 10.498 mega electron volts. Also, instead of doing gamma and mc squared, I could have just said gamma times mc squared is 10.511 mega electron volts, since gamma times mc squared is the total energy. And we like to do pc because it has units of electron volts, just like the energy. Okay, and then I have to compare its velocity to that predicted by classical physics. Okay, so classically, I would have the change in kinetic energy is equal to Q times delta V. So that would be 1/2 mv squared, because it's starting from rest, is equal to the charge. I just got to think about how I want to do the units here. So I'm looking for the velocity. So then I can just plug in the charge. 1.602 times 10 to the negative 19th coulombs times the change in potential, which is 10 megavolts. And then I have to divide by the mass and multiply by 2 and take the square root in order to find the velocity. So 2 times 1.602 times 10 to the negative 19th coulombs times 10 megavolts divided by the mass, which if I put the charge in coulombs, then I want to do the mass in kilograms, which is 9.11 times 10 to the negative 31 kilograms, and that gives me 1.875 times 10 to the 9th meters per second. But in order to compare that to the 0.998 C, I'm going to divide this by 2.998 times 10 to the 8th meters per second, and then multiply by C. And that gives me a velocity of 6.26 C. Can it be? No. So that's clearly wrong because it's much faster than the speed of light. Another option for calculating the velocity classically, we could use units of electron volts. So I would have the same expression here. So this would be 1/2 mv squared is equal to E times delta V. So that'd be 10 mega electron volts. And then when you solve for the velocity, you would be taking the square root of this times 2 divided by the mass. But we don't know the mass in units of electron volts. We know mc squared is 0.511 MeV. So we could say this is mc squared, but then you would have to multiply by c squared, which is fine because that would give you, when you take the square root of this c squared, that would give you the c, which would be the c that we have there. So this is the square root of 20 mega electron volts divided by 0.511, and that should give you 6.26 C. And that concludes problem 15.